What's up, everybody? I want to do a video today going over a LeetCode problem, but this time doing it in Solidity. So we have a pretty simple problem here, but there's going to be a few kind of, not really tricky parts, but a few parts we have to kind of overcome that wouldn't be available, that would be easier in a different programming language. So I figured I'd do it in Solidity and kind of talk through it and kind of talk through my thought process. So pretty simple situation from here. We're given a temperature in Celsius, and that is coming in as a float, right? So say float here. It's coming out as a decimal point here, and we're going to convert that into Kelvin and Fahrenheit, and then return both those answers in an answers array, Kelvin and then Fahrenheit from here. Now, if you know anything about Solidity, you know that decimals don't really work in Solidity, right? There's a few libraries out there that I think might be able to work with them a little bit here, but just for the sake of this video here, we're going to keep things kind of simple. We're going to kind of use some not made up units here, but we're going to use what I'm kind of calling. Let's go find my contract here. We're going to use K way and F way. So a lot of times when you see contracts dealing with way, it's something divided by 10 to the 18th power. So, if you're familiar with way and Ethereum from here, if I just type in ETH to way converter, 1 ETH is equal to 10 to the 18th power way. I think, is this the right one here? So 1 ETH, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's how many way per ETH here. So 1 degree in Kelvin is going to be equal to this many Kelvin way here. So we're kind of using this kind of made up term, made up unit of measure just to help us out here, right? Now, a lot of times what you would do, or almost all the time what you would do, is you would have a front-end interface that kind of does the conversion from Ether, from the main unit to that way unit before it reaches a smart contract from here. So we're assuming that whoever programmed the front end is intelligent enough to know that that's what they should be doing from here, okay? So a little bit of a workaround, a little bit of a cheat here, but that's kind of the way that we're going to do it right now. And that's the way you see it done a lot of times in Solidity. You take a number, you convert it to a way version of that number, and then this way you can work with floating points from here. So the first thing I'm going to do is I'm going to build a function here, and this is more, actually the first thing I'm going to do is I'm going to build out the contract. We're going to say convert the temp. We're going to open it up here. Now, it doesn't always have to be way here. So what I'm going to do is I'm going to build out a little helper function, and this is going to be function, and this is going to be get decimals. And you see this a lot here. Basically, a front end interface or whatever can call this to see how many decimal points we're moving that number over, and then this way they kind of get the correct number back, if that makes sense there. This is going to be a public pure, and this is going to be returns a uint 256, and we're going to open this up from here. And all that we're going to say returns, returns space 18. I can't type. There we go, 18 here. So that way if somebody comes along and they call this function here, I did something wrong there, public returns, what's the matter with that there? Expected primary expression, returns 18, returns uint 256 there, public pure, get decimals. What is wrong with that there? Returns 18. Oh, I'm sorry, return 18. There we go. So this way, if someone's to come along here and they're interacting with a smart contract, they can call this function first to see what conversion they have to make in order to get the correct numbers on their front-end interface. All right. So this is more of a helpful function from here. Cool. So let's continue building this here. Remember that in this function from here, what we want to build here, this is Rust code, of course. We're taking in the initial temperature and we're converting that to Kelvin and Fahrenheit. Cool. So function, get out of here. We're going to call this convert the temperatures. And that's fine for now here. What I'm going to do now is I'm going to ignore the parameter. We're going to deal with that in a second here. This is going to be a public, a pure, and this is going to be returns a uint 256. It's going to return an array from memory. And let's open this up from here. All right. Now we have to take into consideration what are we taking as a parameter. We're taking a uint 256 here. And this is Celsius way. Now, do keep in mind here that we're dealing with unsigned integers. Just for the constraints of this question from here, it says it won't go below 0 degrees Celsius. So I know a lot of times, if you live, many of places, anywhere above, I don't even know, But yeah, where I live, it gets below 0 degrees Celsius quite often. So actually, you can kind of see it's almost below 0 degrees Celsius right now. So at first, my first of the problem, I assign these as integers, but I think because we're dealing with the question set here, let's keep it as a unit right now. It's an unsigned integer, something above 0. All right. So first up, let's go and declare an array. This is going to be a uint array, and this is going to be memory, and we're going to call this answer from here. Now we know that we have two different things that we're going to return in here, so we're going to put 2 as the length of the array there and 2 right there. All right, and we're going to be returning this in a second, so we can say returns, or return I should say, answer. Cool. And we have something wrong there. Convert the temperature, uint 256, public pure returns. Cool. So now we need to take in we need to convert the number that we've taken in here. So we're going to say uint 256, and this is going to be k way, and this is going to be equal to Celsius way plus, and the conversion here is Celsius plus 273.15 here. So 273.15. Now remember, we need to convert this number 2 here, because if we try to add this, maybe it actually says it right there. If we try to add this, it's not going to work. So we want to move this decimal point 18 places over here. So we're going to get rid of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Cool. Now let's go ahead and say answer at position 0, because let's double check that. I believe Calvin comes first here. Yep, Calvin comes first. At position 0 is going to be equal to k way. Cool. So this is halfway done here, and this is actually the easy part. Now we also have to convert this to Fahrenheit, uint 256 f way. Now this one's a little more tricky from here, because if we look at the formula, we have Celsius times 1.8 plus 32. Now again, if we try to use this decimal point from here, it's not going to work, right? So if I say, Celsius way times 1.8, and we try to do that, it's simply not going to work. And it's not as easy as just moving this point over either, because then you end up with a massive number. You're not multiplying it by 1.8 anymore. Now you multiply it by an insane amount here. So what we're going to do, if we think about this 0.8 number here, that's basically 4/5 of that amount here. So we're going to take Celsius way, and let's just go ahead and divide by 5. So essentially this gives us 80% of the total value from here. This gives us 20% of our total value from here. But this isn't what we want. We also want to multiply this by 4. And let's go ahead and put some parentheses here. Even though that would probably work just fine here. Now we're equaling 80% of our initial value from here. So we have 0.8, but now we also want to add that 1, 2 here. So I'm going to say Celsius way, plus this right here. So this is the 1, and this is the 0.8 from there, right? So now we have Celsius way times 1.8, but we also want to add in that 32 here. Now in this case, we want to add in those 18 zeros here. So 32, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Cool. And I'm going to add in one parenthesis just to make sure this does the math properly here. And then final step is to add this to the array from here. So we're going to say answer, ants at position 1 equals, I can't see what I'm typing, f way. Cool. And this is looking pretty good. This feels pretty good to me from here. Okay, so the first thing I want to do here is let's go ahead and compile this here. And mine's on auto compile. Let's go ahead and deploy this contract. Cool. So let's go ahead and get decimals. Cool, 18, that's what we would expect here. First thing, let's try, go back to here. Let's try 32 degrees Celsius. So 32 degrees Celsius, we should have about 90 degrees in Fahrenheit. Remember, we're taking it in as Celsius way here, so 32, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hopefully I typed that incorrectly here. Convert. Cool, so the first position there. So it looks like we're off a little bit there. Oh no, we're correct here. It just didn't pop to the next line there. All right, so 305.15. Let's see if this can convert to Kelvin. 305.15, looking good there. Let's go back here. Now another use case here, if you're ever talking about dividing stuff here, you want to make sure this can still, if you put in 0 here, what happens now? Right, 0, we have 32 degrees Fahrenheit, and we have 273.15 degrees Fahrenheit, or excuse me, Kelvin from there, all right? So hope this helps you guys out here, especially a lot of times with Solidity doing simple stuff like having to multiply by a decimal. You have to do some weird things like this. So you have to kind of think about how the numbers are structured and kind of how they're built on top of each other. So hopefully you guys learned something. If you guys did, be sure to give me a thumbs up, comment down below, and subscribe. And I will see you guys in the next video.